All right. Hi, welcome everyone to our computational and tech careers in the life sciences career panel. We have some very interesting panelists that were LifeSci alum, and we're very happy to have them present and talk about their experiences in the panel. Um, yeah. So we're from the LifeSci NYC Internship program. So the LifeSci NYC Internship Program is part of New York City's Economic Development Council's 10-year, $1 billion initiative to grow the life sciences industry in New York City. We offer paid internships and part-time and full-time opportunities for college graduates in either the sciences or business track, management track. These include, a lot of different data, tech, and computational type jobs in the life sciences, and they're very varied. Since 2017, we've placed over 800 interns at over 200 companies and organizations. So there's a company and role for everyone. So the two panelists we have today is George Kinafati, was actually my classmate when I was a student at City College. He's currently a data analyst at NYU Langone, and Tamar, who is a bioinformatics programmer at NYU Langone Health. So there's a very wide variety of different sort of opportunities in different sort of environments and organizations in data tech and computational sciences. I guess we can introduce the panelists. Is George and Tamara, you could introduce yourself, like talk about your background and how you got to your position and things of that nature where you studied. Uh,
Um, oh, sorry, George. Hi, thank you. So my name is Tamara. I actually did my undergrad at City College, after which I did an internship that summer at New York Stem Cell Foundation. And while I was there, I actually didn't have in mind to actually do anything in computational biology or bioinformatics track. However, in that experience, I was really, it opened me up to different fields because NICEP has been working on a computational end as well with a lot of their data that they're producing. And that's where I really kind of thought that that could be a possible role for me. Um, After that, after I finished my internship, I started working at Columbia University. So I did a lot of wet lab work. And then after my first year there, I actually applied to do my master's at NYU in the bioinformatics and computational end. And it was very helpful to have that wet lab background so that I knew the biology that kind of went into producing a lot of this data as well. And then once I wrapped up my master's, I joined my current role, which is at NYU Langone, with, I guess, George is also there. And so I'm in the ABL program. So, well, that's the lab. So it's Applied Bioinformatics Lab. And I'm also in the plastic surgery department. So a lot of my work currently right now is based on patient samples, so clinical samples. We do a lot of different data analysis, so mainly machine learning. I've been also doing a lot of single cell RNA sequencing analysis. And overall, it's definitely been a journey going from wet lab to dry lab and bridging that. But again, I think it was extremely helpful for me to have both of those backgrounds. So now that in my current job, I feel like I have a wider scope and a bigger understanding of some of the data that I'm actually receiving and looking at. And yeah, I'm very excited to be here.
Hi everyone, my name is George Kinafati. I actually also did my undergrad at City College in Macaulay Honors, as John mentioned, and I majored in biomedical engineering. I graduated in 2020, like graduated virtually during COVID, and right now I'm at NYU Langone as well as a data analyst, in a research lab, but my path to getting there, wasn't really direct at all. So at City College in BME, City College BME doesn't really have a focus or any tracks for specialization. So I was always interested in more neural engineering. Um, and I volunteered in a research lab doing some MRI work. And I also interned at Soterix Medical, um, which they do transcranial direct current stimulation, but my role was more so, I mean, I learned 3D printing, but if you really categorize it, it was kind of just like marketing almost. I was helping to make models and images for um like the materials of the documentation of the product. So it wasn't engineering heavy, but I did learn 3D printing. So those were my skills. I never really learned uh programming in undergrad. It was required, but I really just couldn't pick it up. And then I did a master's in biomedical engineering at Columbia. I graduated from that in 2021. So I did it right after the undergrad, and it's an 18-month program. That's when I actually picked up programming. I learned both Python and MATLAB at like a beginner level. And now working at NYU, I've been able to like really grow that skill. So I'll speak more about it later, but I've grown that skill at work. And what I do at work is my lab studies chronic pain. We're looking for a biomarker of chronic pain, and one way of doing that is through human data because my lab also studies animal data, and we're looking at specifically EEG as well as some intracranial data through collaborations. And we're looking at things like frequency power difference during acute pain, etc. So it's heavily based in Python, and honestly, it's mostly statistical analyses and like methods established in EEG. Not much machine learning, even though it's part of my skill set, but it's because that part of the research is kind of just growing.
That's very interesting. I guess so like what type of courses and experiences did you find most helpful in preparing you for your career? Um, yeah.
Hi. So for me, kind of what George was talking about, I think machine learning and learning how to work with different AI models, especially for the work I do right now, was pretty imperative in a lot of ways. And a lot of it is, as George was talking about, Python based. There's a lot of not only is it Python based, but it's great for image analysis as well. And so a lot of the work that I do in particular is looking at different patient samples and trying to understand patterns within that. And so I would definitely say machine learning was a big component of it. And that is something also, to George's point, you could pick up through work and through internships as well, as you're kind of going along in your journey. Because it's not necessary. It's definitely great to be introduced early on, whether you're taking courses in it, but it is also something that you could pick up as you're working through this career. Yeah.
Uh, George, you think you're muted or?
Can you hear me now?
Yeah.
Yeah, so for me, the courses that helped with my computational skills in Columbia, the Columbia Biomedical Engineering Masters is like, I think one of their mottos is like you will leave knowing how to program. And they kind of really hammer that in. So they have like some required courses where you can't escape it. Like you need to create some kind of model. And those were mostly in MATLAB. So then that helped with like learning to think as a programmer, but my skills that I use on a day-to-day are from specifically from deep learning courses. those were like deep learning for biomedical imaging and then also biomedical signals. And those helped more for learning how to program, like think about how to program or think as a programmer, and then also like best practices in Python. Um, it's simple, it's all simple, but there's ways to like, get better at it specifically for a specific use case. So personally for me, that's what did it. And then on the job, I always like at first I just started to I was kind of like results oriented. I just wanted to get something done at work. So I was just using like the elementary knowledge that I had. Um, and I was coding a lot in like Jupyter notebooks. But then slowly I was like thinking to myself, I think I could improve my skills and especially make my work more efficient. Um, and also learn at the same time. So I slowly started to improve my skills beyond what I learned.
That's that's great. And both of you are coming from um like biomedical engineering, biology background. When did you get more interested in more data and the computational side of the life sciences? Or was it like just a slow process that you kind of, self-discovered that you were interested in, or you just happened to get a job and you followed down that track? Like, could you elaborate more on each one of your journeys?
Well, for me, it was when I was working at Columbia. There's so much data out there, and especially like different imaging data or data in the sense of like protein marker levels, et cetera. And the field was really, the idea is that with having a bioinformatics background or a data science background, it allows you to explore the data in a different way. And it also allows you to garner answers in a different way. And so for me, that was kind of the moment where I decided like that could be an interesting way to start looking at some of the research that is currently going on and finding different hallmarks and biomarkers or pathways that might be a bit elusive when you're just doing simple, not simple, but when you're just doing wet lab work. So I think in conjunction, the two really work together. But
Uh,
For me, what drew me to a computational focused career was when I was like kind of in the middle of the master's. I was thinking to follow more of like a entrepreneurial path in terms of I was really interested in engineering for like low resource economies and helping people in like really rural communities get access to certain things like diagnostics. And I'm still interested in that. But being at Columbia, I had the opportunity to take like way more in-depth neural courses in neural engineering. And I just felt like I had finally found something that I felt I was pretty good at. And even though I honestly really disliked, I always wanted to learn coding, but I really just couldn't pick it up in undergrad. So um, finding that I was actually picking it up in Columbia, it was pretty like motivating. So that's when I started to embrace that new career path. And I had an internship during my time at Columbia. I was interning at a company called Alpha Omega, and they do DBS surgeries. They make the drive that uh, puts the electrode for therapy into the brain. So I was working in the OR, and that was a really cool experience. But knowing that I had just learned so many skills, like in analysis, I kept wanting to do some more of that work with them. And they're based in Israel, so I kind of always got the answer that it's not like we would love to, but all our R&D is in Israel, and you're doing a great job at what you're doing now. So I knew that I either was going to stay there for like 3 to 5 years and just work in an OR, which is a great job, but I would eventually lose a lot of the skills that I just gained. So I knew that I had to really stick to what I just found that I would be really good at. So in my last semester at Columbia, I took a course in EEG that was hands-on, and we learned a lot of like very specific methods for analyzing EEG data, whether it's a lot of it is task-based, like for doing brain-computer interface stuff. But a lot of those skills just really happen to align really well with the job description for my current job. And I think I got it was a little bit of luck, you know, it was preparation, but it was also luck that job had come around the same time. And besides that, lining up, I think that I realized that computational skills, regardless of the domain, are really useful in a wide range of applications. So if you ever become interested in another field, you can take some of those skills with you. And I mean, software engineering is not super related. You know, it's pretty hard, and it's a separate skill set on its own. But as an example, if you wanted to sort of break into that, you at least have some kind of base, even though you started in some kind of like engineering, you know, such as biomedical.
Uh, That's a very good advice. So since both of you work in like academic medical centers, which is, you know, not traditionally seen as like where most aspiring, you know, data scientists or software engineers or people in the more computational side end up going, how do you interface, like how is it working in that environment compared to maybe other environments that you have worked to that is different, or you know, that you didn't really expect until you worked in it? And like how do you collaborate with others, like maybe wet lab scientists or clinicians? You know, could one of you like attest to, like, you know, the challenges and the opportunities working with, you know, within an academic medical setting?
Um, s- well, I guess for me, kind of progressed in my career is a lot through mentorship, and basically the people that I have built relationships with in the sense of research. A lot of my mentors are in the research field currently, which has been a kind of like a guiding post as to like the next steps that I want to take or how I'm picturing myself and, you know, like the long term. So for me, like going from NYCEF to Columbia to Langone, all of my mentors currently have, you know, are professors. So I am interested in staying in the academic field, probably long term. So for me, it hasn't been so much of a big jump, I guess, from like an industry. I guess NICEF was the in between that I had. But for me, I kind of always stayed in that, you know, research focused environment. So I think it has a lot to do with the mentors you make, the people you kind of trust with the work that you are producing and that you're doing. And I think that's a really good person or people to lean on to kind of guide you in what you're interested in.
Yeah, so academia for me has been different than what I'm used to for sure. I mean, I don't have that much time outside of school before my current job, but there are some differences. I think there are some really great differences. For example, in my specific case, I don't think this is the case for everyone, but there is a little bit less pressure to perform in terms of like results and like deadlines, things like that. It's not, there isn't much pressure because like I said, it depends on like what stage of research you're working on, but for me, we're at like a very basic stage of like kind of discovery. There are, of course, there are theories and you know, there are already models for the way that chronic pain works. But we are exploring. So there isn't like I'm not really on the team. Like I'm pretty much the only person working on this data. So that's a bit of an advantage where it's kind of like a theme of discovery and just trying to get insights from the data. And I think that's a benefit because it gives you time to improve your skills. You're not always just focused on handing a task off to the next person. However, I guess there are challenges because in my specific case, I don't have like a PhD or a postdoc right above me who is let's say, for example, like in industry, I guess there'd be like a senior data analyst or maybe even just a data scientist above me or just a PhD or a postdoc. My lab has one postdoc. So um, I think that's, at least in a smaller lab, that's a challenge in academia where you could have a little bit less guidance. Where in industry that won't really happen. You know, you have someone to report directly to, and sometimes too much of that. You know, people in the industry complain of like bureaucracy or just feeling like they're in a little bucket. But anyway, I think they both have their pros and cons, and other than that, I think um, in the academia could be little limiting in terms of what you're working on in the moment, but there is always opportunity to collaborate, and I think NYU Langone is kind of known for that. Um, at, at least in my lab and the labs that I know, they collaborate heavily. So sometimes they may feel that way that you're working on something very niche, but I think it's a double-edged sword. So you're able to overcome it.
That's really great and interesting to hear how um, working in an academic medical center, has its like, advantages. And if you want to stay close to research, but not exactly doing the research, it's a good opportunity to be involved on that side. Um, why I guess like you've been in the, I guess, field for a couple of years now. Why would you recommend a career in computational sciences, data and tech um, for like aspiring students, especially in for the life sciences?
Well, at least in my experience with what I've been working in, well, so even with the med students, like at Langone, like a lot of them use like VR headsets to like start practicing different surgeries. A lot of the data that I receive as well, like clinical patient data, it does correlate with pathologists as well. Like you end up working with a lot of different people, a lot of different teams. And so, at least from my experience and how I feel about it or see it, is that the two fields are pretty much parallel to each other in the sense where a lot of the data that is being produced, it's something that both in a computational end could find answers and as well as in the wet lab end. And so I think it's pretty much has become a part as well of the field in a very integral way. I definitely think even if it's something that might not be the end goal, that as George was saying, I definitely think it helps and improves a lot of your skills while you're within this life science field as well. So.
Vidar, sorry, can you please repeat the question?
You've been in the field for several years. Like, why would you recommend students to, pursue um, the life science industry from like a computational science, data, or tech angle?
Right.
Like,
So I would recommend it because first of all, I think you can learn this stuff with the wet lab basis, which I think is what Tamara is was talking about as well. Um, and I think in health tech or in biotech, um, there is a growing industry in analysis and like omics, and I've been seeing it a lot. Like I've been attending panels or conferences for like entrepreneurship and startups, Silicon Valley or New York City. Regardless of the location, I think there's a huge push for using AI in tech and um, in general. Just it seems like there is a growing need for just the way that there's more. It's a weird analogy, but like there's more computer chips in a car, like year over year. Um, it seems to be the same thing in most industries, and now it seems like that's what's in demand. For example, like I mentioned, entrepreneurship. I'm exploring that space on my free time, and Y Combinator has like a blog post. I think they do every year. It's like requests for startups, and one of them is a cure for cancer. And I think they focus on AI, and obviously that AI isn't the only career path you can have in like a computational sense. Um, but it's really hard to ignore that that's like a growing need in most industries. And you don't need to know AI to have a computational career in the life sciences. It's just a testament to the fact that it's a skill that's in demand. And for me, I can say that I know that it was very intimidating for me to get into. However, from like for example, I just know I know Python, I know MATLAB, and I've tried to learn R. So I, I've taken some courses and I haven't really like done any projects in it. However, just from like an hour or two of like LinkedIn courses, I could say that I could probably do something simple. So I'm I just bring it up to say like I know it could be very intimidating to try to learn a new language or think like a programmer when you haven't in the past, but there are tools that make it easy for you, and like tutorials. So if you just spend the time to try to learn them, you'll see like the value in them.
That's great. And then on that note, like where do you see the fields that you're working in like evolve over the next like 5 to 10 years? Where do you see um where do you see, I guess, and how do you feel like you're going to fit into that, into those trends?
Um, well, specifically for me, or kind of the work that I've been doing, as I've kind of already alluded to in a lot of ways, I do see this field very heavily connecting with just like clinical and medical diagnoses as well, like working hand in hand in that in the next couple of years, where it's not that pathologists would rely on it, but they would use it as a tool, as just as a part of their repertoire of the number of things that they're going to do. I also think it's very evident with students, how different students like PhD students, med students, they will be using AI as well, I think, for in a sense of learning. But additionally, it doesn't, like George was saying, doesn't have to be AI, right? I think it's also in a question of when you think about population genetics, or even like with global warming and climate change. I do think the data science component is going to give us, it's going to be very heavily incorporated into better understanding and shaping the way we see life sciences, or maybe shaping it in a different way for us to understand it maybe better. So.
And like, what particular skills would you recommend a student, to gain, like whether it's like inside or outside the classroom, that you would find like the most valuable?
Well, for me, honestly, it's been, I would say a lot of it has to do with my mentors. Like I really do. Like there's a couple people in my life that I think really kind of like was George talking about, it is daunting to learn any new language, right? Just in general. And when you are starting out, it is very important to have the right mentors to like guide you in the sense of the work you want to do. And then if you are lacking that in any way, or you haven't found that person that you kind of see yourself, or kind of like see yourself in a couple of years, then in other cases, it would be also just experience, right? So whether you're at home and you want to do some coding, or you know, because you could download, because a lot of the software it's for free, right? You could just download R, you could, you know, get Conda, and you could use a lot of that stuff. So you could start practicing on your own, whether it be through YouTube channels, or whether it be through LinkedIn. I know they have like certificates and courses that you could take. And so there's, I think a lot of people have already provided like some niche things online for you to start using these tools as well. So I think those are the two things that I think might be influential in some ways to kind of figure out where you fit in that.
So for me, I would classify like my field more broadly as I would say data analysis. To answer the question about the 5 to 10 years, I don't want to answer just for chronic pain, because this is the lab that I work in now. It's not like my thesis. However, to answer that first, I would say for chronic pain, I think there's a need to make the knowledge more cohesive, because like for pain studies specifically, there is no pain cortex in the brain. There's something referred to as like a pain matrix, and it's quite distributed. So there's a lot of different data and results out there in the community that don't really align. So there is, specifically for chronic pain in the next 5 to 10 years, there needs to be some kind of like glue that holds it together. But more broadly, I would say the trends for data analysis in biomedical data. I'll say the obvious one first is that people think that AI will take people's jobs, but I've heard a quote that represents it better, that people who learn to use AI as a tool are the ones that would replace those jobs. So personally for me, I started I would say like in the fall, coding with ChatGPT, or the language model of your choice, and it's drastically improved my skills. Like I'll say, hey, can you make this more Pythonic or more efficient? There's different ways you can improve, what you're optimizing for. So I asked it to be more Pythonic, which just means like follow the guidelines for good Python practices, and then can you make it more efficient? Because these are things that we don't learn as engineers, especially in like a rapid course like masters. We don't learn how to make things efficient in Python, because that's kind of like a software developer's job to make things like really snappy. So I would say that's my biggest suggestion as a trend. Like, when don't be ashamed if you don't know something. Use it as a tool to like just learn and implement it. Like for example, like I'll just be really transparent. I didn't know what a decorator was in Python, and I think really most engineers don't really need to. But I said, hey, I have this code. I think it could be used with a decorator. Can you show me how? And it spat it out, and I tried it, and then you decide whether you keep it. So I think that's a good way to. It's like multifaceted. You can improve the code, which improves the project. You do your job better, but you're also learning for yourself. You're making yourself, stay current and grow your skills for other, if you're going to move down to another, if you're going to move along to another job down the line. And I would say it for anyone interested in, besides, I would say that engineering or life sciences engineering and computational careers are very related to entrepreneurship. So for anyone interested in that, since I'm exploring that space myself, which is actually how I that was my internship at LifeSci. It was at a startup. For anyone interested in that space, I would say find a mentor at your university who has that expertise, or someone in LifeSci, because with a support network, it's really, I won't say easy, but it's an attainable goal. If you have that like bug, people call it, the startup bug or entrepreneurial bug. If you have that interest, don't be intimidated. You see like, oh, people need to raise this much money, or you need to be CEO, you need to hire people. Don't be intimidated. I think you're supposed to fail. That's kind of the thing about it. You're supposed to not know what you're doing. So that's another trend. I think people in the next 5 to 10 years will really be exploring growing their own ideas, start industries, etc.
Mhm. That's good to hear. We'll going to open up the I guess floor to questions from the audience. Please just put it into the chat. Before then, I want to share a link some links for our internship program. Um, application, the bunch of opportunities, office hours, and our meetup. So, please please look at them at your convenience. I guess if anyone has any questions, please put it into the chat, and then George and Tamara will answer them. Yeah. Any brave soul?
While we're waiting for questions, I wanted to suggest for people interested in Python, what really helped me learn was on Kaggle. There's a website called kaggle.com for competitions, but there is a post called Hello Python by someone named Colin Morris, and it was just like a very fun tutorial. That person made it like really fun to learn Python. So on Kaggle, it's called Hello Python by Colin Morris, if anyone's interested.
Mary says, were there any courses or programs that helped you during undergrad?
Tamara, would you like to go first?
Oh, sure. Well, I would, because in my undergrad, I didn't do any actually computational or any of that. I actually just did biology. And so because I wasn't sure yet what I wanted to do. I wasn't sure if I wanted to do my PhD or where I wanted to go with it. But I would say one of the courses when I was at NYU that really kind of like solidified a lot of concepts for me is when I was doing it was a statistics in R, which was really, really helpful because what you realize is that they're very simple functions that you could run, and it gives you just a fantastic output of information. And so that was really great to see. And I think it's also, it helps you kind of understand or at least kind of work through the anxiety of sometimes working with math and computational biology, or just like the data science component of it. So that was a really great course for me. Dr. Katari taught it there, and he was a great professor. So that was definitely a good one, but I don't know. George?
Yeah, for me personally, in biomedical engineering, there was only really one course in undergrad that taught programming, and that was digital signal processing, and that was in MATLAB. So it was good for learning digital signal processing, not really for learning coding. Um, However, I want to make a comment for, in general, those courses, uh, uh, like computational courses in engineering. A pet peeve that I have, I guess, is that they'll teach you in the most like efficient format for the course, which is like Google Colab or Jupyter Notebook. However, that's not the best for actually learning or for doing it on the job. For example, I was working a lot in just Jupyter Notebook for work, and I thought to myself, like, be the right way. And so I looked into it, and software engineers, they work in VS Code, and it's not just for software development, it's also for data science. And I took the time to learn it. And by time, I mean just like one 15-minute YouTube video. None of this stuff is like, there's no, there shouldn't be any barriers. So there's like profiles that you could download with one click for setting up your VS Code for data science. And I highly recommend it because working with like trying to do Git version control on Jupyter Notebook or just working only in notebooks, like it's really inefficient. And I could speak more on that if you'd like. You could totally feel free to email me.
Another question is, what were some common technical questions at the data and bioinformatics interviews?
Well, for me, so my first real bioinformatics job was right after I finished my master's. So I entered Langone. So when I was interviewing, and again, George might have a bit of a different take on it because I think he's been to more of an industry setting for it as well for the interviews. But when I was entering the academic realm of this, a lot of my interview questions were basically to see, it's the notion of like being able to finish a project from start to finish to actually just produce something and to then interpolate that production. And some of the skills was obviously like the language skills. So whether it's like Linux, R, Python, etc., like to what are the languages that you know? And then also your GitHub. So I don't know if you guys have a GitHub or if you've worked with GitHub before, but it's a really great place to kind of have a lot of your repositories. They don't always have to be public. They could be private. You could be working through it. But I would definitely recommend starting to kind of like get familiar with GitHub and working with GitHub and putting some of the work there. And what's really great is that there's also a lot of I know I feel like I hammer down on a lot of the notion there's a lot of data out there, but there is, and there's a lot of public data. And so you could actually begin working on with a lot of public data that is out there and start putting repositories out there on your GitHub. And so that's kind of was a very important link for me. To provide my GitHub, to provide the languages I know, the courses I've taken, things I'm interested in. So, yeah.
And for interviews specifically for my role at NYU Langone, the questions were really specific to the project. They were like, this is what we're doing, and are you familiar with it? It was kind of like they weren't the like intimidating questions you hear about for industry, like behavioral questions, things like that. It was really just like with a whiteboard showing me what they're currently working on and, kind of understanding whether like I'll speak about what I know. And then to a certain extent, they kind of interview your body language too. Like, do you really understand it? And do you know what you're talking about? So it's good to be honest because you don't want to oversell. You want to know that you're going to do the work that's needed, and then you're going to learn at the same time. And then I did have some some interviews for industry before getting my job at NYU, and those were different. For example, one that sticks out was that a company worked very heavily in MATLAB tables, and I wasn't familiar with the actual object tables in MATLAB before that, but they mentioned they were going to send me like a quiz to see how well I could do with MATLAB tables. They didn't follow up with that. But anyway, that's something that you could face where they are they work in a very specific like format. Some companies don't want you to switch languages because everything is in MATLAB or everything's in Python. So it would be counterproductive for them if you were to use the language of your choice. So, and yeah, I second Tamara's suggestion about GitHub. I think I don't think all jobs will require it, but um, for me at work, like I taught myself just because it's actually useful, especially when you're like I started working with someone else who is helping me on projects, and for us to send each other code on by email is just, I mean, it's like really archaic and it's counterproductive. Like you will cause more frustration. So GitHub, it has a little bit of a steep, or Git version control has a bit of a steep learning curve, but it's really rewarding. You'll get the hang of
Um, do you have any advice for someone who's currently an undergrad who's applying for a master's? Anything you wish you knew when applying?
Um, well, I think, at least for me, um, so this is this is very particular, I guess, to like, my journey and like what I'm working on, is that, so when you're applying, right, you kind of really want to see, what labs they are, what professors there are, right? Because you're going to be doing your thesis work there, right? And so you want to make sure that, um, the thesis and the work that you want to produce, right? There is a lab that, it doesn't have to be obviously similar. It's not really, I mean, that's not always going to happen, but somewhere where you could see yourself, like the projects that they're working on or the people in that lab, the things that they're working on. And then also seeing where those people, the alumni go after that lab, right? To kind of see the trajectories of people. And then also to look at, the output of that lab in the sense of, or like in those areas where it's like how many papers they're coming out with, or what are they working in particular. So I think that's a really, it takes some time to kind of understand exactly, which lab is going to be your best fit. But I think once you start anything, whether it be a PhD or a master's, the thesis work that you do it is an important component of it. So knowing what labs they are there, the people that they're working with, and their collaborations, I think is very important. So.
it. For me, I think you should get a good sense of what the curriculum is gonna provide for you in the master's. So for me, I like I said, I was thinking to do something completely different, and Columbia Biomedical Engineering has that. But then as it ends up, they also have the specialization in neural engineering and a very strong one. So that's, I think, super important to consider. And then second, I think there, for example, with Columbia, if you're going to apply to ones in New York City, Columbia has, specifically for BME, it has like one of the oldest BME programs in general. So that means it's very strong. Um, that's something to consider. And then third, I think the network. I'm grateful that I chose Columbia because it is, on face value, it is, I guess, up there in terms of tuition costs. However, I'm still seeing the benefit of that. Like I'm able to join, like I get emails for like really cool events, and I'm able to join them no problem. I'm like 2 years out of graduation, and they treat you like an alum, like you're just, or they treat you like a recent grad. You're welcome back. Um, and with Columbia, that's even more so. Probably the same thing for NYU. So I don't think you should choose a program based on only like the name and the network, but it's definitely very helpful.
Another question, what would you say is the benefit of applying for internships through LifeSci as compared to other job sites like LinkedIn? Like, how has your experience with LifeSci been helpful in your career journey?
Well, well, for me personally, I think it's just the community, right? It's like all the alumni working together. It is these different panel discussions, or even just, the people who are participating in the program on just different levels. And you do build a sense of a network, right? So if you do have trouble in general networking, which is because it's very daunting to learn how to network, right? Because it's not something we're taught all the time. I think this is a very good space to build that network and to just branch out, and like George said, like, we're now a network as well for you guys, and that's, I think, the component of LifeSci. So.
Mhm.
And I want to offer a different perspective. You want to apply through LifeSci because of the other half of the reason that LifeSci exists. It's for the companies. They're getting interns, and they don't always have to pay for it. So, I don't want to speak out of terms, but they're, different company applicants for LifeSci will have different requirements for what they which part of the compensation they pay for. But in some cases, they're getting an intern for free or at a very low cost, and that's very attractive for them, especially with a low budget or a startup. So they want you. They're LifeSci's making their job easier for finding great candidates, and it's helping them to get them at a lower cost. It's for them, it's somewhat of a no brainer. So um, I would say that you're at an advantage applying through LifeSci rather than just their website, for example.
Yeah. Uh, Thanks for the free marketing, George. I guess like we're running out of time. I guess we can end with this question. Um, and this is directed to George, but tomorrow you can also chime in as well. So George, you said you were coming out of Columbia. You knew how to code at an elementary level. How did you go how did you go about marketing yourself to your current role? A lot of internship and job postings I've seen require at least 2 years of experience.
Yeah. I still applied to the ones that said like 2 plus, because I think the basic reason is that there weren't a bunch that were 0 years of experience. So definitely still apply to those. And then in terms of marketing yourself, I would say to some extent you have to just say like, yes, I have those skills. Um, Especially because some things you can learn later on. But I think in the computational field, like, and maybe for every field, but there's a certain extent where like things are overcomplicated and they're made to seem more intimidating than they have to be. So, like there are fancy terms, fancy terminology, and you might hear and say, "Oh my God, like I don't know that." And I can never learn it. I'm too late. And that's never true, honestly. Like, this is such a random example, but like, let's say SVM, right? Support vector machine for machine learning. It sounds like so hard. Like, what even is that? But it's really just like one equation, and if you really took the time, if you already know coding, you could teach yourself how to write one from scratch. So, um, you just have to kind of say like, I have those skills, or if not, I'm really willing to learn on the job. And another thing is like if they ask you for your weakness, you have to like pose it really well. Like, oh, I get lost in the details, but then I come right back. So always make things in a positive. Not like, oh, I just don't have that skill. It's I don't, but, and then you make it a positive.
Um, well, I also additionally, I guess one of the ways that you could showcase yourself is when you are doing these, let's say these interviews, or where you're applying for this, is that because I don't think the expectation is necessarily that you need to know every single language, right? Or the expectation is that you need to know every single different ways to approach it, right? There are things that you could be specifically interested in or very good at, and then in that sense, you could market yourself in that one particular skill, maybe that. In the sense of like presenting some of the work you have done previously or including that as part of your resume. And that's where, you know, with GitHub or any of those platforms, you know, that you could showcase some of the stuff you've done already. And I think that is, again, very helpful for, you know, when people are looking at you or your portfolio, they do want to see if there is, if you could finish a project, wrap up a project in any way, because those things do become valuable, right, to your employer as well. So
That's great to hear. And I believe that both George and Tamara said that anyone can connect with them on LinkedIn. If you want to, you know, bring the conversation offline and network with them offline, they're happy to do that. That's also a great thing about, you know, being in the LifeSci program, where you have access to a lot of different alums and, you know, to us as well, you know, even after you pass through the program. So we highly encourage you to apply, and good luck with the rest of your semester and your job and internship hunt.
Yeah. Good luck, everyone.
yeah, good luck, and you guys appreciate it.
And thank you, George and Tamara, for giving your valuable insights. It's always great to see alums give back to the program and inspire the next generation of interns and students. Yeah.
No, yeah, thank you for having us. Yeah,
Of course. Thank you for having me as well.
yeah.
Good night, everyone.
Bye, guys.